For more, let's go to Leicester in England and Jonathan Nichols of the Department of Physics and Astronomy at the University of Leicester. Thank you for speaking with us here on France 24.
Thank you.
So, do you believe? Is there life on one of these 7 planets?
Well, if you are going to believe, then it's a great place to believe about. I mean, these 7 planets around one star is unbelievable. If it was 7 planets around a solar type star, that would be interesting. But it's 7 planets around a tiny little red dwarf that really should have no business having that many planets.
Yeah, explain to us what a red dwarf is.
Okay, so stars come in different sizes. The sun's is yellow, it's a middle type star, but the smaller ones are cooler and they look red, you see, and there are plenty of bigger stars that look more blue. But the thing is, these red stars, these tiny little red stars, are very, very common throughout the universe. And so they're really interesting because if you can find planets around those types of stars, as we indeed have, then it means that there are so many planets in the universe.
Now, of course, we can dream about it all, but it's 39 light years away.
Yeah, that's right. 12 parsecs, or for the Star Wars nerds, that's 1 Kessel run. So we're not going to be going there anytime soon, but in cosmic distances, that's actually really close. And so that's the reason why we've been able to get some great data about this star system and been able to see the little dropouts in the light when these planets go passing front of the star, and the shadow that we can see then tells us that there are these 7 planets. It's remarkable.
And it was done thanks to having these telescopes all around the globe.
Yeah, that's right, both on the ground and in space. So many of these observations were made by a telescope in space called the Spitzer Space Telescope. And these telescopes are all trained on this one particular system in order to find these planets. But the next thing that we need to do is look at this again using the Hubble Space Telescope in order to try and find what the atmosphere of these planets are like.
What the atmosphere of these planets are like, and we saw on the chart there's sort of the 3 in the middle. They look like the most likely ones that could have life on them.
Yeah, that's right. So the place around a star where you can have liquid water is called the habitable zone. That's where we think it's most likely place to find life. Now, the thing about this star is because it's very small and dim, that means the place where you can have liquid water is very close. Now, that's good because all of these planets orbit very close. So all of these planets, to some degree, might have some liquid water on them. And that's really important for finding life.
Jonathan Nichols, what's the object of trying to find planets that have life on them?
Well, I think most of us, to some degree, whether we're astronomers or not, we're interested in the idea of there being life elsewhere in the universe. It's one of the key science questions that drives many different ways of observing the solar system and life and stars. And so really the overall goal here is to find out whether we're unique in the universe, whether life evolved elsewhere. And one of the great things to find is planets in the habitable zone around stars.
So what could they teach us about planet Earth?
Well, it teaches us a bit about planet formation. In fact, many of our ideas about planet formation originally were based around our own solar system. Then we started finding exoplanets around other stars, and that really challenged our ideas. But this one is a real curveball. The number of planets around this tiny little star is huge. There's no business that being that many planets around this star. And so what the next thing is we need to do is we need to twist our planetary formation models in order to understand how you generate this many planets around such a tiny star.
And they rotate at very different speeds.
That's right. They're rotating, they all orbit the star at particular periods. Now, it's very similar to the Jupiter system in our solar system, where you have 4 moons, and for every 1 orbit of the inner moon, the outer moon makes 2, etc. And it's the similar way. So you've got these planets orbiting, all affecting each other and all going around in a kind of cosmic harmony. And that, I mean, that in itself is interesting, but it also raises interesting issues about what the interior structure of these planets might be like. Are they hot? Are they volcanic because of tidal forces on these planets? It's a really interesting system to think about.
The building blocks, though, are they the same everywhere around the universe?
Yeah, wherever we look, we see the same kind of chemicals and the same kind of elements that make up life. The things that you're interested in for life are the chemicals that are there, the temperature. Is it hot enough? Is there a source of energy like a star or geothermal activity? Is it stable? Has it been around for long enough? And these stars live a hell of a lot longer than the sun does. And is it stability? So you need all of this, all of these factors in there to make a habitable area. And these planets have this lot in troves. It's a great system.
Jonathan Nichols, if there was one premise that's either been confirmed or debunked by this discovery, what would it be?
It's about how we know about how planets form. There's really no business being this many planets around a star that tiny. So I think the interesting fact about this is, how did those planets get there? How were they formed? Why are there so many? And are there any more?
What's your idea on it? What's your hunch?
Well, I think that this is telling us that actually what we thought we knew about planet formation really isn't that good. What we need to do is we need to go ahead and find more of these systems, and it will tell us how many of these Earth-type planets there are in the universe, and that will really help us in the search for life. And if you just imagine sitting on one of these planets, you would see 6 other planets in the sky. You'd see the sun about 10 times the size of our sun. It would be glowing red. It would be a really great place to stand.
All right, we're going to leave it there. I want to thank you, Jonathan Nichols of the Department of Physics and Astronomy at the University of Leicester.
All right, thank you.